Hello. I wanted to record a short video to review the chain rule and the product rule, which are two rules that you'll be using extensively when you're doing derivatives of complicated functions. Now these rules you should have learned in calculus, and most likely you've used them quite a few times before. But what I'm looking to do with this video is to help you review those and show you some situations that come up in some of the problems that we're going to be solving in dynamics. So to start off with is the chain rule. Now the chain rule simply says that if you're taking the derivative of a function with respect to a variable such as time, that's going to be equal to the derivative of that same function, we'll call that function y in this case, in terms of another variable, in this case we're saying x, times the derivative of that variable x with respect to the variable t. Now when I'm looking at this function, what I'll typically do is I say if I want dy dt, I'll say, well, I know that's going to be equal to dy, the derivative of y with respect to something, I'm going to leave that blank for now, times the derivative of that same thing over the derivative of t. You notice how I have the dy and the dt. Now what I fill in the open parentheses depends on the particular equation. Let me give you an example. If you had an equation, let's say the square root of 25 plus sa squared, and you needed to find the derivative of that, we're going to call that function y. Now most of the time in dynamics we're finding the derivative with respect to time, because that is the relationship between position and velocity, where velocity is the derivative of position with respect to time, and acceleration is the derivative of velocity with respect to time. So often we're doing with respect to time, but it doesn't really matter what variable we're doing it in. In this case, if we wanted to find dy dt, I would say that's going to be the derivative of y with respect to something times the derivative of that same thing with respect to time. That's the chain rule. Now what I fill in those parentheses, I look at the equation and I say, well, what I have in the equation is an sa. I have the variable sa. So if I can find the derivative of that function with respect to sa, I'm going to go ahead and fill that in here. Derivative of y with respect to xa, I just need to multiply that by the derivative of sa with respect to time, and I'm going to have my chain rule. So in this particular equation, we can find the derivative of y with respect to sa. We'll do that part first. That's just this part. The derivative of y with respect to sa is going to be equal to 1/2 times 25 plus sa squared to the negative 1/2. But then you have to go inside the parentheses and also multiply that by 2sa. So that whole thing, we just used a chain rule right there a second time. So you have a nested chain rule. If you don't see that right away, you can do another substitution and you could say, okay, well, let's say function p is equal to sa squared. Then my y is now equal to 25 plus p square rooted. And when I take the derivative of that, I'm going to end up with my 1/2 times 25 plus p to the negative 1/2. Now I have to multiply that by dp dt. Now dp dsa, which is what I got here, the 2sa. So I used a chain rule there, but I still need to use another chain rule, because what I found here is just dy dsa. Now I need to find dy dt. Well, dy dt is simply equal to dy dsa times dsa dt. So my dy dt is equal to 1/2 times 25 plus sa squared to the negative 1/2 times 2sa times dsa dt. Okay, so that's the chain rule. And now, of course, we could simplify. We could say dy dt equals. The 2 and the 1/2 go together and cancel out. We're going to put the SA on top. Then we have a dSA dt, and we know that the derivative of position of point A with respect to time is just going to be the velocity. On the bottom, we have this 25 plus SA squared, square rooted. And that would be dy dt. So you notice that we use the chain rule twice. Hopefully that refreshes the chain rule for you. It helps to do a lot of practice with the chain rule. I would say the biggest mistake I see with students is they forget this. They forget the dSA dt. And I believe this is just because of math. In math, a lot of times in your math classes, if I were to ask you what the derivative of 2x is, you would most likely tell me the derivative is 2. That's because in math, most of the time, you have a function of y with respect to x. And you almost always take the derivative of y with respect to x. Well, in engineering, we have many variables. And the derivative that you're taking at that time depends on what you're looking for. If we were taking the derivative with respect to time of the equation 2x, it would be 2. And then you'd have to take the derivative of it. Let me write it out real quick. dy dt would be equal to dy dx times dx dt. That would be equal to 2, which is our dy dx, times dx dt. Got to make sure to use the chain rule and remember all terms of the chain rule. Feel free to ask me questions if you have any about the chain rule. I'd like to move on now to the product rule. The product rule is when you're taking the derivative of two different functions, and these functions are not constants because you can pull constants out of the derivative, and these functions are multiplied together. You've probably seen this out of your textbook or out of a math textbook. The derivative of uv, where u and v are multiplied together, dt, is equal to u dv dt plus v du dt. If it was a math textbook, the only difference is you probably would have seen an x down here instead of a t. It depends on what variable you take in the derivative in terms of. Now I'm going to modify this slightly. I'm just going to write the exact same thing, but I'm going to use a and d, and you'll see in a minute why I chose those two. So if I have the derivative of some function a times some function d with respect to time, that's going to be equal to the first one, which is a, times the derivative of the second one with respect to time, plus the second one times the derivative of the first one. Okay. In a lot of the situations in dynamics, you're going to be using the product rule when there's three functions multiplied together. So what I want to do is show you how that works. So what I'm going to do is I'm just going to say, well, what if d is actually a combination of two other variables, b and c. So if d is equal to b and c, I'm just going to go ahead and substitute that into our equation. Now we have the derivative of a times b times c. So we have three different equations there. With respect to time is going to be equal to a times the derivative of, it was previously d, I'm going to plug in b times c here. I'm sorry, with respect to time, plus d, which is now b times c, times dA dt. Okay, now all we have to do is look at this. We have another product rule to do. We have a nested product rule. So I'm going to go ahead and perform that product rule, and we'll just say that the derivative of bc dt is equal to the first one times the derivative of the second one plus the second one times the derivative of the first one. There we go. Now we have the derivative of bc dt, and we can go ahead and substitute that in right here. So we're going to have the derivative of a times b times c with respect to time. It's going to be equal to, if we substitute that in, the first term we get is a times b times the derivative of c. The second term we get is going to be this a, this a multiplied by that, which is going to be a times c times the derivative of b. And finally, we add on the b times c times the derivative of a. Okay, so all we did there is we expanded the product rule so that we have three functions multiplied together. And when you look at it, the way I like to remember it is the derivative of three functions is the first two, a and b, times the derivative of the third, plus the derivative of the second times the other two, plus the derivative of the third times the other two, and so forth. So the derivative of one times the other two functions, plus the derivative of the other, the next one times the other two functions, plus the derivative of the third times the other two functions. I'm going to go ahead and also record an example problem where I go through and use both the product and chain rules. I'm going to go through example 12.217, so feel free to watch that video as well. Also, feel free to come to office hours or ask me any questions that you have. Thank you. I hope this was helpful.